Good day, all of you. This is Dr. Monmas. So I will give you this theory part of physics so that when you are now in class, you will be able to concentrate to do questions. So today's topic, we weight and body accelerating vertically. We need to understand that a body in a level environment, it has two forces which are acting. You can see that force N there. The force N there is the normal force. Like when you put something on top of a table, that table is going to exert a force onto that body, and that force is going to be the force which is going up. Actually, the body is going to exert a force going down. Example, you are sitting on top of a chair. You are injecting a force on that chair. That force is called mg, which is the weight force, and the chair is exerting the same equal force, the normal force, or the sort of a resultant force, resisting your weight. That force is going upward. So what we are saying is that when a body is stationary, what happens? According to the second law of motion of Newton says that F is equals to ma. F is equals to ma, and F is a force. And let's take example of that diagram there. The weight force is F is mg minus the N, and that should give us ma. If mg was greater than N, it means that body is going to be going what? Down. But because mg and N are equal, we have the movement there is zero. The movement there is what? Is zero. So that's why we say that the body will be at rest. The body can only be at rest according to the second law of Newton when the force which is attempting to cause movement is the same as the force which is attempting to resist what? Movement. So in other words, we can say that when a body is stationary, example, we have a pot on top of a stove. That pot there on top of a stove, we can see that there's no movement there. Or a book on top of a table. It means that the force which the book is existing when it's on top of the table is the same as the table is existing. The force of the table which the table is exerting to counterpart the force which the book is exerting. You will forgive me on that pronunciation of the word. So now let's go to another example. So in this example, we can see that suppose the lift accelerates down. When that diagram there is the lift, the only situation whereby the lift can accelerate down is whereby the mg is greater than what? Than the N. Therefore, the acceleration is going to go where? It's going to go down. Example, let me say you put like a stone, you drop a stone, you put a stone of, let me say, 5 kg on water, and the stone goes down. Or you go, or any example whereby the mass is going to go down. It means that the force which is acting down is greater than what? The force which is acting down is greater than what? It's greater than the force which is going up. So, and the weight of the body is mg minus a. So weight is less than mg. Body feels as if weight weighs less. So this is the example which I wanted to share with you. But what happens when the body goes up? When the body goes up, when the body accelerates up, it means that the N force, the force exerted by the table, is greater than the force what? The mass is exerting downward. This is how we need to understand it. This is how you need to understand it. So you are going to do an examples to understand it. So work, energy, and power